Hello grade 8. Today in this video we will explain the covalent bond. So let's start. Covalent bond, if you remember in the previous video we spoke about the ionic bond, and we said an ionic bond it's a kind of bond between metals and non-metals, and one gains electron, which is a non-metal, and one loses electron, which is the metal. But in this covalent bond, we don't have losing or gaining, we have sharing. So what happens in covalent bond? It is a bond that forms between the non-metals only. Atoms, when they share electrons, the same number of electrons to complete the outermost energy levels of each atom. And from the previous videos also we spoke about the valency electron, or the electrons in the outer shell, and we said that atoms, they tend to have 8 electrons in their outermost energy level, because in this case the atom is stable, but they share the electron in between. Like when you and your friend share the same pen, you write with a pen for a while and then you give it to your friend to write with the same pen for a while. In this case, both of you are sharing the same pen or pencil. Atoms, they do the same. They share electrons in between. Okay? So we have types for covalent bond. We have single, double, triple bonds. Okay? So let's see examples for covalent bond to understand more what does it mean. Each hydrogen atom has one electron, and it needs another electron to complete the first energy level, which carries only 2. So in this case, each hydrogen atom shares one electron with the other hydrogen atom. So in this case, this hydrogen atom will have 2 electrons, and this atom also will have 2 electrons, and this called covalent bond. So as we said in the hydrogen molecule, one hydrogen plus another hydrogen. Each hydrogen atom has only one electron, and it needs to make it needs to make 2 electrons in the outer shell to be stable. So in this case, what happens? Each one of them participate or shares one electron, and they keep the electrons in the middle. So one time these 2 electrons will orbit this nucleus or this hydrogen atom, and one time the two electrons will also go to the other side. So in this case, the 2 atoms share the 2 electrons for hydrogen molecule. Let's see also another example for covalent bond in water molecule. Here we have the 2 hydrogen atoms, and here the oxygen atom. Oxygen has 6 electrons in the outer shell. So how many electrons it needs? It needs 2. From where the oxygen atom will get these 2 electrons? From hydrogen atoms. Each hydrogen atom will participate with 1 electron. Look here, this hydrogen atom will participate with its 1 electron, and also the other hydrogen atom will share or will participate with also 1 electron. Oxygen will have 8 electrons in the outer shell, and the oxygen will be stable. And also the hydrogen atoms will have the 2 electrons that it needs to fill the energy level that it has, because we said that hydrogen needs only 2 electrons because it has only 1 energy level. And also the other hydrogen atom will have also 2 electrons, and in this case will be stable hydrogen. So they form water molecule. So water molecule is made from or has covalent bond. Here single bond and here single bond. So this is the water molecule by covalent bond. Okay, so now we will see, as we said, the oxygen atom shares 1 of its electrons with each of the 2 hydrogen atom. It now has outermost energy filled with 8 electrons, and also the hydrogen atom share its 1 electron with oxygen atom. Each hydrogen atom now has 2 electrons, and this will be filled, the outer energy level will be filled. Okay, we express this diagram by another form, by the dot diagram. In the dot diagram, we write the symbol of the element, and we write only the electrons of the valence electron, or the electrons in the outer shell. If you remember, we said that oxygen has how many outside? 6 electrons. So the red dots represent the valence electron for oxygen. We put or the hydrogen puts its electron in the outer shell of the oxygen, and also this hydrogen will do the same. So in this case, oxygen will have how many in the valency electron? Will have 8 valency electron, and the hydrogen will have 2, and the hydrogen will have 2. So this is a molecule of water. So molecule consists of 2 or more atoms joined in a definite ratio. Like here, when I say that a water molecule is made of 2 hydrogen atoms to 1 oxygen atom, this is what's meant by definite ratio. A hydrogen molecule is composed of 2 covalently bonded hydrogen atoms. However, most molecules are composed of atoms of 2 or more elements. The model in figure 2 shows 2 ways to represent the covalent bond in water molecules. So here we can represent the covalent bond by this diagram, or also by this diagram. Both of them are ways to represent the covalent bond. Okay, so now we understand what is a molecule. The molecule made from 2 or more atoms joined together by a definite ratio. Okay, so any 2 atoms joined together, we call them a molecule. One way to represent atoms and molecules by, as we said, the electron dot diagram. In the electron dot diagram, it shows only the valency electron. As we said, we only show the valency electron in the atom. Electron dot diagram can help you predict how atoms might bond. To draw an electron dot diagram, write the symbol. We write first the symbol of the element, or the letter for the element, and place 1 dot around the symbol for every valency electron in the atom, as shown. Place the first 4 dots alone, and then pair them. Okay. So, for example, carbon has only 4 valence electrons, so I will put 1 electron in each side first. And then we finished the 4 electrons, so we will not make pairing for electrons. But look here, for example, for oxygen. Oxygen has 6 valence electrons, so how we do this? First, I put 1 electron in each side, and then how many left? 2. So I keep, then I make pairing for electrons. I put 1 electron here and 1 electron here. It doesn't matter. You can make the pairs here and here. It doesn't matter. So krypton here has 8 valence electron. How I will do this? First, I will write the symbol Kr, and then I will make distribution for the electrons. I will put 1 electron in each side, and then I will make pairing until I finish the 8 electrons. So I will put 1 here and 1 here and 1 here and 1 here, and then I will make pairing. I will put the other 4, 1, 1, 1, and 1. So in this case, I made the electron dot diagram for krypton. For hydrogen molecule, we can do this also for molecules. Hydrogen 1 with 1 atom, with 1 hydrogen here with 1 electron, and the other hydrogen with another electron. So the 2 electrons between the 2 hydrogen atom, and we call this the shared pair. So when I ask you how many electrons are needed by carbon to complete its outer energy level, the answer will be 4, because it has 4 and they should be 8. So carbon atom needs 4 electrons to complete its outer energy level, and in this case they can form covalent bonds with other carbon or with other elements. Oxygen has 6 electrons, so how many electrons needed by oxygen atom? Oxygen atom needs 2 electrons to complete the outer energy level, 1 electron here and 1 electron here. Krypton, it has 8 electrons in the outer energy level, and this is one of the noble gases. So it has already complete outer energy level, so it doesn't participate in any kinds of chemical reactions, because it doesn't make any bonds with other elements, because it's already stable. Like helium, like neon, like argon, they all are the same, noble gases, and they are in group 18 in the periodic table. In the water molecules here, what will happen if you take out some of these water molecules or you break down the water into smaller molecules? You will still have water. But what will happen if you break one molecule of the water? Because when you break it down, it will be 2 hydrogen atom and 1 oxygen atom, and in this case you don't have water anymore. Okay, so when we remove the molecules away from each other, we still have water. But when we break down the molecule itself, one molecule itself, we will not have water anymore because they are hydrogen and oxygen atom. Okay, so the water in this fishbowl is made up of many tiny water molecules. Each molecule is the smallest particle that has the chemical properties of water. Each molecule from this has the same physical and chemical properties of water. So when you have only one of these molecules, you still have water. When you break it down, you will not have water anymore. The simplest molecules, we have two types of molecules that form from covalent bond, simple and complex. The simple molecules, like the diatomic molecules here. Di means two atoms together. So when two atoms, they join together and they have shared the electrons in the middle, we call them diatomic molecule, such as oxygen, nitrogen, halogens. Atoms have filled outermost, like here. The fullerene has 7 electrons, and this also has 7 electrons. So what happens? They share, each fullerene atom share 1 electron in the middle. So in this case, if we remove this atom, we will have here 8 electrons, and also here we will have 8 electrons. And in this case, the two fullerene atoms will be satisfied because every one of them has 8 valency electrons, and this will make the atom to be stable. So this molecule, we call it diatomic molecule because it's made from two atoms together and they share a pair of electrons. Like here, the two atoms, this has 7 valency electrons, and they bond together to form the diatomic molecule of fullerene. Let's see now the more complex molecules, and actually they are everywhere, like the sugar, like wood, like most of the food. Even in your body you have this kind of complex molecules. Like saccharose, this table sugar molecule made of carbon, hydrogen and oxygen atoms, we call this complex molecule. Most of complex molecules made of carbon atoms. The carbon atoms are the basis of many of these complex compounds or complex molecules. Each carbon atom needs, as we said, 4 covalent bonds to have 8 valence electrons. These bonds can be with atoms of the same element, or they can share the electrons with other elements, like as we see here, hydrogen and oxygen. Okay, grade 8, so this was everything for covalent bond. In the next video we will speak about the metallic bond. Take care of yourselves and see you soon. Bye bye.